Okay, ready for sample problem number 2? Here we're going to have to use a lot of our kinematics and dynamics information that we had from our Physics 20 course. A small rocket is on its launching pad and has a mass of 50,000 kilograms. Its rocket motor can exert a force of 2.2 times 10 to the 6 newtons for 10 seconds. What is the maximum kinetic energy of the rocket? What is the maximum height the rocket can reach? You can assume that the mass of the fuel spent is negligible and that the change in acceleration due to gravity is trivial. I know I told you have to draw a picture every time you start. In this case, you're just going to have your rocket going up. It's going to go up, it's going to reach its maximum height, and it's going to come back down. And we're going to look at the energies happening. So the first set of energies that we have to look at is why, like what's happening down here? Why is it going to start moving at all? And then we have to find out how we're going to get this high. Let's write down what we know. Okay, now that we have all of our information written down, what are we going to do next? Where are we getting our kinetic energy from? It's going to be from that force from burning the fuel, right? And so it tells you in the question that the rocket motor is exerting a certain force, this 2.2 Newton force, and it's doing it in 10 seconds. So what do we know about kinematics and dynamics from Physics 20 that can help us with this? Well, first off, we know that our force net is always equal to mass times acceleration. So we can use that information to then find out what our acceleration is. Here's what we're looking for. EK is equal to a half mv squared. We need to find our v. Burning the fuel is going to take the rocket from not moving at all to moving at its maximum speed in a very, very short amount of time. That max amount of speed then is going to slow down, slow down, slow down, stop, and then come back down. We need to use our net force to figure out what our initial speed was. So the first part is to get our acceleration. So acceleration is equal to force over mass, which is going to be our 2.2 times 10 to the 6 newtons over 5.0 times 10 to the 4 kilograms. That means our acceleration is going to be 44 meters per second squared. I do not have that in proper significant digits because it's not one of my final answers. So you can, and I often encourage you to keep a few extra decimal places because this divided beautifully. I did not need to, because it's an exact number. So now we know that the rocket ship wasn't moving before this force was applied. So our VI is equal to 0, and what we're looking for is our VF. The VF then, we're going to be able to find using one of our kinematics formulas. Hopefully remember our kinematics formula, where A is equal to VF minus VI over T. And we're going to solve that for VF. And we can actually take our VI here and have it be 0, which means that it cancels out of the equation, which means VF is equal to A times T, which is 44 meters per second times 10 seconds, which means that our VF is equal to 440 meters per second. We can take that now and put it into our kinetic energy formula. EK equals a half mv squared, and we can solve for our maximum kinetic energy because this VF that we found over here, we're going to sub that in to here, giving us our maximum kinetic energy because that is the maximum speed that was reached from the force given. Okay, so we've got 1/2 times 5 times 10 to the 4 kilograms times 440 meters per second squared is going to give me a maximum kinetic energy of 4.84 times 10 to the 9 joules. Now, as we talked about at the beginning, we have our kinetic EK max here. We're going to have our EP max at the top height. So if EK max equals EP max, we can use this to find our max height, MGH. So you've got your EP divided by mg is equal to your h, and you've got 4.84 times 10 to the 9 joules over 5 times 10 to the 4 kilograms, 9.1 meters per second squared. Again, remember that you put this in brackets. You should get your maximum height to be 9.87 times 10 to the 3 meters. So our final answers are here. If you have any questions about these, make sure that you email me.